This lesson we're going to know how to solve radical equations, right? And then we have to remember that we're going to check for extraneous solutions, which are solutions that would make the statement false, right? So after you substitute it back into the equation, it doesn't make sense. You get like 5 equals 10 or something like that. Okay, and we're always going to check for these solutions when your index is even, okay? Not so much when it's odd, not necessary. And the first step for all of these is to get your radical alone. So remember, if we have a fractional exponent, that is a radical, right? So that is going to be something we need to get alone, and that is going to be something we need to get alone. Okay, so let's kind of remember something. If I get the square root of x alone, this is really x to the 1/2 power, right? So what I'm going to do essentially is square both sides, but I'm actually raising it to the reciprocal exponent, right? So I want you really to think about this because the exponents being in fractional form are really going to be helpful to you, okay? Because that's just going to give you an x, right? Which is what we want. We want whatever's inside to come outside. But we're not going to do that until we get it alone. So let's go ahead and get this guy alone. So we have the square root of 2x minus 3 is equal to 5. Now, right now we could just square both sides. It could look like this, square and square, because when we square a square root, that fixes it, right? But I really want you guys to think about it as 2x to the negative 3 to, or minus 3 to the 1/2 power. So this is technically what this looks like. So that's why when I square both sides, this goes away. And so we're going to have 2x minus 3 is equal to 25. And when I add 3 to both sides, I get 2x is equal to 28. And dividing by 2 will leave me with x is equal to 14. Now, this is my solution, right? But I need to see if it's extraneous. So I need to see if it will mess up my statement. Because my index is even here, I'm going to go and check this. So 3 plus, and then we have 2 times 14 minus 3 is equal to 8. Let's see if this works out. So this is 28 minus 3. So this is 3 plus the square root of 25 is equal to 8. Well, this is 3 plus 5 is equal to 8. So yeah, that works out. So we can keep that. That is our solution. So the pink part is us checking the solution, and the purple is finding the solution. Okay. So we go to this one, and we see that we have rational exponents, so we're going to get that alone. So first we subtract 1, and we have 6 times x plus 3 to the 2/3 power is equal to 24. So when we divide by 6, we're going to get x plus 3 to the 2/3 power is equal to 4. So like we were saying, we're going to raise this to the reciprocal exponent in order to get 1. So this will go away and this will go away, and we'll have x plus 3 is equal to, now I want you to look at this. 4 is actually 2 squared. So actually, let's put it next here. So this is going to be 2 squared to the 3/2 power. So this would go away and I would get 2 cubed. And so 2 cubed is just 8. And so we would subtract 5 from both sides and we would get x equals 3. Now, this is our solution, and we don't have to check this because our index was odd right there. Our index was odd. The bottom number was odd. Okay, let's go to the next one. Okay, so let's get this guy alone, which means we're going to divide by 3 on both sides. And so we have x plus 3 to the 3/2 is equal to 8. And so we will be raising this to the reciprocal exponent, which is 2/3, which makes a 1 here, which plays very nicely. But 8, remember 8 is 2 cubed. So this is really 2 cubed to the 2/3. So the 3's will go away, and we'll be left with 2 squared, which is 4. So we get x is equal to 1. And now we have an even index, so we're going to check our answer. So we have 3 And then we're going to put 1 plus 3 cubed equals 24. And so this is 3 times the square root of 4 cubed. Okay, so 4 cubed is just 2 times 2, 2 times 2, 2 times 2, if you think about that. So when we take this out, we're going to have 4s coming out, right? Because if I have 3 of those, right, obviously we're going to have 2 times 2 times 2 coming out, which is 24, because this is going to be 3 times 8, and that's going to be 24. And 24 equals 24, so we are finished. All right, next one. First, we'll add 7 to get our radical alone. Now, a little reminder that this is to the 1/2 power, so we're going to be squaring both sides. But the difference here is that I have a binomial on the other side. So when I square a binomial, that's x plus 7 times x plus 7. So you would multiply this out, and you would get 7x, and then 49. Let's move this over. Oops. So we will get plus 49. And so this guy will turn into x squared plus 14x plus 49 equals, and then this is just x plus 7. But this is a square root, so we are going to have to check our answer. So because we have a quadratic here, we are going to get a 0 on one side. This is not new to us. And we will get 0 is equal to x squared plus 13x plus 42. Okay, so when we factor this, this is going to be x plus 7, x plus 6, which means our solutions, after we set these equal to 0, are going to be x equals negative 7, 7, and x equals, negative 6. Okay, we have to check these answers. I mean, these are our answers, but we have to see if we're going to be able to keep them. So we go back up to the original, and that is the square root of negative 7 plus 7 minus 7 is equal to negative 7. We're just substituting x in. So this is the square root of 0 minus 7 is equal to negative 7. Well, that works out, right? So we can keep this one. Now let's try the other one. So the square root of negative 6 plus 7 equals negative 6 plus 7. So this is the square root of 1 is equal to 1. Well, that is true too. So we get to keep that one. So in this case, we have 2 solutions. Don't forget to check them, okay? All right, take care. Bye.